In this lesson, we'll be discussing linear and exponential. By the end of the lesson, you will be able to contrast graphical representations of linear and exponential data and use tables, graphs, equations, and words to determine if a relationship is linear or not. So if it's exponential, in your table you're going to have a growth factor, which means you're multiplying by something. In a graph, you're going to see a curve. It'll look like it's starting as linear, like a line, and then you'll see this explosion. With the words, you're looking for something that says doubles or triples or 25% or cut in half. Anything like that will indicate that it is exponential. And your equation, instead of having an x like mx, you're going to have x as an exponent, so it's going to be small. So when we contrast the equations, in linear, it's y equals mx plus b, and m is your slope, and b is your intercept. With exponential, this a, y equals a times b to the x, a is your intercept, and b is your growth factor. So when you look at a table, you look at the y, and you can see in this one that it's subtracting 1. That's our pattern. So that's linear. In this one, we're multiplying by 6. 1 times 6 is 6. 6 times 6 is 36. So our equation is y equals 6 to the x. And you can see in the graph, the linear one makes a straight line, and the exponential is the curve. So for example, a tropical storm in Texas is causing rain that's doubling every hour. Complete the table to determine the amount of rain after 3 hours. So as soon as you see that word doubling, you have to know that it's exponential. Then it says that we're going to complete the table. So in hour 2, it doubled, so 1.5 went to 3. After 3 hours, it's going to be 6 inches of rain because, again, it doubled. So our growth rate is doubling, says it's times 2. And then rain after 3 hours would be 6 inches. Another example, Ticketmaster adds a service charge of $15 to use our program. Complete the table based on recent purchases. So Sarah spends $115 on 4 tickets. So we'll go here to 4 tickets and we'll write in $115. Karen buys 2 tickets for $65. So we'll write 65 in there. Ticketmaster charges Carol $215 for 8 tickets. So we'll write that there. So looking for our rate of change, look at the change in y, which is 50, over the change in x, which is 2, which means our rate of change is 25, which means each ticket is $25. Our y-intercept, when we buy 0 tickets, is still $15. That's the service charge. Our equation is y equals 25x plus 15. We can put in 7 into our equation for x and multiply $25 per ticket times 7 plus the $15 service charge is $190. So we can tell that this is linear. So if we compare them, if we look at the 2 graphs, again, the curve is exponential and the straight line is linear. If we look at the words, the rodeo has a $5 entrance fee and $1 per ride, so that's going to be linear, where this one, the tree frog, doubles every 3 weeks, so that's going to be exponential. Looking at our 2 tables, this one is exponential because it's times 3, and this one is linear because it's plus 4. So looking at the equations, so a times b to the x is exponential, and our mx plus b is linear. What is x at the y-intercept? X is always 0 at the y-intercept. And where is the y-intercept on the graph? Where it crosses the y-axis.